How to find price elasticity from demand and cost functions? The question is, suppose the cost function for a monopolist is C is equal to 3Q square plus 800, where Q is the output. Also, the inverse market demand function is being given as P is equal to 280 minus 4Q. P denotes the price. What is the price elasticity of demand at profit maximizing price? Okay, so we need to find out that very stuff. Okay, we are being told to find out the elasticity of demand at profit maximizing price. Okay, for a monopolist, what is the profit maximizing condition? And let me write it here. Simple thing, for monopolist, profit maximization condition is that his marginal revenue should be equal to marginal cost. Okay, okay, that means we need to find out the marginal revenue, and for to calculate the marginal revenue we need total revenue. Okay, and to get the marginal cost we need the total cost function. Total cost function is being given us. Okay, and a total revenue function we need to first form. Let us see what we are being given. We are being given the total cost function is 3Q square plus 800. This is the total cost function. From total cost function we need to calculate the marginal cost. Simple thing, marginal cost is simply equal to uh, you know the derivative of cost function with respect to output. Taking partial, taking derivative of this function with respect to q. Derivative of q square is 2q, so 2 into 3 is 6q, and derivative of a constant is obviously 0. Okay, so we got the marginal cost. Also we need to find out the marginal revenue. So to find the marginal revenue, first we should know what is total revenue. Total revenue is simply price into quantity. And let us see also what is our inverse demand function, that is P is equal to 280 minus 4Q. Okay, if this is our inverse demand function, from that we can find out the total revenue. Simply total revenue is equal to price into output. Okay, P is this very stuff, so in place of P I can write 280 minus 4Q. To this I multiply with this Q. This will give us the total revenue, which is 280Q minus 4Q square. Okay, this is our total revenue function. Now from total revenue function we need to find out the marginal revenue. Marginal revenue, as I told you, is simply the derivative of total revenue function with respect to output. That means differentiating total revenue function with respect to q. Derivative of q is 1, so we are left with 280. Derivative of q square is 2q, so 2 into 4 is 8q. Okay, now what is the profit maximizing condition? So let me write it here. I know it got very messy. So profit maximization requires our marginal revenue should be equal to the marginal cost. Marginal revenue we calculated, it came out to be 280 minus 4, sorry, it is 8q. 8q, it should be equal to the marginal cost, which we calculated as 6q. Okay, so itaron your or so that means 14q is equal to 280, which implies uh, q is equal to 280 divided by 14, which gives us 14 ones are 14 twos are, that gives us profit maximizing output equal to, that means the value of q comes out to be 20. This is our profit maximizing output. Now we also need to find out the profit maximizing price. Okay, so we got profit maximizing output as 20. To find out the profit maximizing price, and let's write it here. So profit maximizing price will be equal to, let us see what is our inverse demand function. This function to this, in this function we need to insert this profit maximizing output. So we have 280 minus 4, in place of q we have 20, so let's write it here 20. So this comes out to be P is equal to 280 minus 4 into 20 is 80. This comes out to be 200. Okay, so profit maximizing price is 200, and profit maximizing output is 20. Okay, so we are done with this. Let us see what is Now we are in a position to calculate the price elasticity of demand. Simple formula: elasticity of demand, price elasticity of demand is simply the derivative of you know demand function, and let's write it in this fashion: dq upon dp into p upon q. Okay, so derivative of demand function with respect to price times profit maximizing price divided by profit maximizing output. Okay, so we need to find out this dq upon dp. Now again, we are being given the inverse demand function. So here we can get dp upon dq, but we need dq upon dp. We need to solve this inverse demand function for q first. Okay, so if I write it in this fashion, if I transpose 4q to LHS, it will become 4q positive is equal to 280 minus transposing this p here. Okay, so solving for dividing both sides by 4, so we will get q is equal to 4 7s are, this is 70 minus 1 upon 4p. Okay, now we can calculate dq upon dp. Now dq upon dp is simply the derivative of this function with respect to price. Derivative of a constant is 0, derivative of p is here 1, so we are left with minus 1 upon 4. Okay, now using the elasticity formula, that means price elasticity of demand is equal to dq upon dp. We calculated, it came out to be minus 1 upon 4 times profit maximizing price. We calculated it as 200, and profit maximizing output is 20. Okay, solving this gets cancelled, 2 1s are 2 10s are, so we have 10 upon 4. Okay, 10 upon 4 is simply 10 upon 4. We have 10 upon 4, 4 2s are 8, it goes point, it goes 4 5s are 20. Okay, so price elasticity of demand will be equal to negative 2.5. And what exactly does it mean? It simply means, okay, it simply means if monopolist increases price by 1%, you know quantity demanded will decrease by 2.5%. Okay, so this is how we calculate the price elasticity of demand from the given demand and cost functions for a monopolist. I hope you find this very video helpful. Thank you.